All right, today we are going to finally talk about some shortcuts. Last time we proved triangles congruent, we had to get all three of the sides and all three of the angles congruent to each other to show that each triangle, well, the pair of triangles was congruent. Today we're going to talk about two shortcuts, SSS and SAS. We're going to apply those to solve problems, and we're going to use them to prove triangles congruent. So the reason this works is a special property of triangles, which is triangle rigidity. Okay, it gives us the shortcut for proving two angles congruent. It states that the side lengths of a triangle are given. If the side lengths are given, then the triangle can only have one shape. Like you can't make two different triangles that have the same side lengths. It's not possible. They're going to be the same triangle. Okay, so this is the side-side-side congruence postulate, affectionately known as SSS. Okay, if three sides of one triangle are congruent to three sides of another triangle, then we have congruent triangles. So we don't even need the angles. All we need are three sides. That's definitely a shortcut. That's half the work. Okay, you can see here that each of the corresponding sides is congruent. So we have triangle ABC congruent to triangle FDE. So let's see how this works in a proof. We're going to use SSS, side, 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 in the figure below to prove the triangle ABC is congruent to triangle CDA. Okay, so first we're going to write down our given statements. We have been given some things, first of which is that segment AB is congruent to segment CD. Okay, that was given to us. AB and CD. We also know that segment BC is congruent to segment DA. Here's DA, here's BC. We just need one more side. Now, fortunately, these two triangles share a side. The last side is this one that they share, AC, and we know that AC is congruent to itself. Let me put some segment bars over those before I forget. Don't forget your segment bars. Okay, and we know that it's congruent to itself by the reflexive property of congruence. Okay, and now we have our three sides congruent to each other. Let me mark that. I can use the side, side, side congruence postulate. So I know that my triangle ABC is congruent to triangle CDA. Make sure that you get the order right because the order tells you which vertices are corresponding by the side. I'm going to put it in the middle. Side, side, side congruence postulate. Yes. That was so much easier. Yay. We love side, side, side. All right, look at this one. All right, so we have to do the same thing. We have to prove two triangles congruent. We're after triangle ABC being congruent to triangle DBC. Okay, we want those two. So they gave us some presents. First, we know that side AB is congruent to side DB. That was given to us. Okay, we also know that point C is the midpoint of side AD. Okay, that was given to us. Now, if they're giving you the definition, or if they're telling you that a point is a midpoint, we're probably going to have to use that definition in our proof. And sure enough, If we know that point C is the midpoint, we're able to conclude that side AC is congruent to side DC because of the definition of midpoint. Like, we had to use it. So we know that AC is congruent to DC. Name of a band. Okay. Because of the definition of midpoint. Midpoint. Okay. Now, so far, we have these two sides congruent to each other. Okay, we've got my pink sides congruent to each other. I just need that last side, and fortunately, they share a side. So I'm able to use my reflexive property of congruence again and say that side BC is congruent to itself. BC is congruent to itself. BC. And notice that I don't have to change the order of the letters of BC because it's the same in both of these triangles. I should probably check that, make sure I did the other one in the correct order real quick. Yep. Okay, nope, I messed it up. Wait. Yeah, I messed it up. Okay, look at this. This is what I did wrong. Okay, do you see that in my first triangle, it goes C first and then A second? And then in my second triangle, it's A first and then C second? Okay, I need to change the order of one of these ACs. I should really follow my own advice. Okay, so I'm just going to make that a CA and now we're all good. Okay. These two, the BCs, go in the same order, so we're cool. Okay, so we're going to use the reflexive property of congruence again. Reflexive property of congruence. Okay, now I have my three sides congruent. I'm ready to say my triangles are congruent. So, triangle ABC is congruent to triangle DBC. Okay. By side, side, side. Side, side, side. Congruent. Okay. Okay, we're back. So we're ready to talk about another congruence postulate. So we have to know this: an included angle. Included angle is an angle formed by two adjacent sides of a polygon. So for example, if I look at sides AB and BC here, the included angle is angle B. That kind of makes sense. They make a little trio. Okay, so it can also be shown that only two pairs of corresponding sides are needed to prove congruence. So before we needed three, now we're down to two. So we only need two if the included angles are also congruent. So if I have this side congruent, and this angle congruent, then I can show that the whole triangles, both of the triangles are congruent, is what I'm trying to say. Okay, so here is our postulate. It's called side angle side because this angle is sandwiched in between the two sides. This is our included angle. If two sides and the included angle of one triangle are congruent to two sides of another triangle, and the included angle of let me try that again. If two sides in the included angle of one triangle are congruent to two sides and the included angle of another triangle, then we know that the triangles are congruent. So here we have that. We have AB congruent to EF. Okay, we have AC congruent to DE. And we have their included angles. Boop, boop. So we know that those two triangles are congruent by side angle side. Okay, note. The letters side angle side are written in that order because the congruent angles must be between pairs of congruent corresponding sides. So it's got to be an angle sandwich. Okay, the diagram shows part of the support structure for a tower, and we have to prove that the two triangles are congruent to each other. So I'm going to color code this so I don't make a mistake like I did on the front. It's saying that X corresponds to V. Okay? If you switch things around like I do, this might be a really good strategy for you to borrow. Y corresponds to W. Do you see how they're flip-flopped across? And then Z just corresponds to itself. Okay, that should help me a lot. So I know that XZ is congruent to VZ. That was given. I know that YZ is congruent to WZ. That was also given. Okay, that's these tick marks that show which ones match up. What don't I know? I have two sides. I either need a third side or an angle. Since I don't know anything about this side or this side, I'm hoping that the included angle, which is this one here, that I can get those two angles congruent. And fortunately, I have a theorem for that. I know that those two angles are congruent by the vertical angles theorem. So I'm going to make sure that I go red, green, blue. So I'm going to go X, Z, Y, angle X, Z, Y is congruent to red, green, blue, angle V, Z, W. And I know that because of the vertical angles theorem. Okay, now I've got my two sides congruent, my included angle congruent. I'm ready to say that these triangles are congruent by side angle side. So triangle X, Y, Z is congruent to triangle V, W, Z by the side angle side congruence postulate. You can just write SAS. Cool. All right, next. Okay, let's talk about what we know. We know that, okay, we have to prove these congruent to each other, these two triangles. Let's mark them in colors because that helped me a lot. A corresponds to D. B corresponds to itself. Okay, that makes sense. And C corresponds to itself. Okay, well that's easier than the last one. Okay, so we know that BC bisects angle ABD, and we know that side AB is congruent to side DB. I'm going to start with the sides. So side AB is congruent to side DB. Okay, that was just given to me. Okay, now I have another side. These triangles share side BC. Okay, anytime your triangles share a side, that's like a present from the math gods. Okay, that side is congruent to itself. And it's in the same order, so I don't even have to worry about flipping the letters. So I know that side BC is congruent to itself. Okay, and I know that because of the reflexive property of congruence. Okay, now all I need, I've got two sides. I just need the angle that's sandwiched between the sides. So I've got this side and this side, I need this angle. I've got this side and this side, I need this angle. Now, this is where my bisector comes in. I was given some precious information. I know that BC bisects angle ABD. Let me write that down. BC bisects angle ABD. That was given. And when I have a bisector, an angle bisector, it produces two congruent baby angles. So I know that this angle is congruent to that one because of the definition of a bisector. So I'm going to say angle ABC is congruent to angle DBC because of the definition of a bisector, angle bisector. Okay, so I have my two sides, I have my included angle, I'm ready for side angle side. I know these triangles are congruent. So I look at my proof statement. This is always the last line of my proof. It's like they gave it to you. ABC is congruent to triangle DBC by side angle side. Ta-da! Okay, I like this one. This one uses some Unit 1 stuff. Okay, so let's start with, well, we know what we need to prove. We have to prove these two triangles are congruent. So let me code them in color. So A corresponds with C. Vertex B corresponds with D. Okay, I just confused myself a little bit. That's fine. It's fine. I understand what's happening. We can, if you need to separate the triangles, we'll talk about that later. Okay. So we know that BC is congruent to AD. Those should have little bars on them. Would you please add those? If I haven't added them for you, those need bars. So BC is congruent to AD, and that was given to us. So that's this and this. Okay. We know some information about another side. These triangles share side. Okay. So if I look at the order, in one triangle it's BD and in the other one it's DB. Okay, so just make sure that you're watching the order. So BD is congruent to side DB, and that is our friend reflexive property of congruence. Okay, so I have two sides congruent. Now all I need is an angle between those sides. Wouldn't it be great if I knew that this angle was congruent to this angle? Well, I have another piece of given information. I know that segment BC, oh, that should really have lines over them too. Segment BC is congruent to segment AD. So let me write that. BC, did I say congruent? I meant parallel. BC is congruent to AD. Those segments are parallel. Okay. Parallel to AD. Not congruent, they're parallel. That's these marks. Those are parallel marks. Okay, and that was given. Now, because those are parallel, I have a Unit 1 situation here. I'm going to extend my parallel lines so you can see what's happening. And I'm going to shade my interior. Notice that the two angles that I wanted to be congruent, this one, whoops, I meant to be on my pen. This one and this one are both in the interior of my parallel lines, and they are on alternate sides of my hot pink transversal. Okay, those are alternate interior angles, and they are congruent by the alternate interior angles theorem. So I'm going to say that angle CBD, I started with the second triangle. I don't know why I did that. CBD is congruent to ADB, angle ADB, right, ADB, ADB, yep. Okay, and that is the alternate. Interior angles theorem. I think that's the abbreviation for theorem. I don't ever remember, I just write it out. Okay, so I've got my two sides and my included angle. I'm ready to say these two triangles are congruent. A, B, D is congruent to triangle C, B, C, D, B. Good grief. By side, angle, side. Okay. Okay, I'm going to do example 6 at the very end. So if you're like, okay, I get it with the proofs, lady, I'm good. You can just not watch the end. But if you want to watch example 6, I'm going to do it after example 7. Okay. So for example 7, we have to state whether the triangle pairs can be proved congruent with either side angle side congruence postulate or side side congruence postulate, SSS or SAS, or neither. We have to code the necessary parts, only the necessary parts for proving congruence. So, looking at my first pair, I have these two congruent. I have this side and this side are congruent. I just need a third side congruent, and I can say that these triangles are congruent by SSS. And fortunately, they share a side. This side is congruent to itself by the reflexive property of congruence. So this is my code right there. That's the code. And then I say side, side, side. And I'm done. That's all I have to write. So I did the code and the side, and that's all I have to write. Let me erase these other marks because I didn't need to write those. All right, next, we're going to go across. So for this, I have two pairs of congruent sides already marked. I don't know anything about the third sides. They could be whatever, okay? But I do have a pair of intersecting lines, and those intersecting lines form something very special. They form a pair of vertical angles right there. So I have two sides and the included angles. Okay, the code is the marks, the ticks, the arc marks for the vertical angles, and these are congruent by side, angle, side. That's all I have to do. These are the best. All right, look at this last one on the top row. Okay, I have two sides marked congruent. Okay, I have two angles marked congruent. And then these share a side. Now, look at this very carefully because this one is super tricksy. For angle 1, I have a side, an angle, and a side in that order. Check. Okay, but look at angle 2. This is triangle 2, I mean. If I said angle, I'm sorry. This is triangle 2. I have an angle, and then I have two sides in a row. Beep, beep. Okay, those are two sides in a row. We don't have an A beep beep property. Okay, that does not exist. There's no A beep beep congruence postulate. Okay, so we cannot use SSS or SAS on this pair of triangles. Okay, this is a neither. Okay, we'll find out in our next video that those are actually not congruent. We can't prove those congruent, but we don't know that yet. Right now, we're just going to say neither. Okay, next row. So I have a pair of congruent sides marked. Okay, and then I have another side that's congruent by the reflexive property. But look at this. On my angle is not my included angle. I have another situation where I have angle, and then I have a side, and then another side. Beep, beep. Okay, these, I cannot say that these are congruent because I don't have an included angle. That angle is out, not in between those sides. Okay, same thing up here. I have my angle, and then I have a side and another side. Angle, beep, beep. Okay, this one is neither. Okay, we don't have a congruence postulate for bad words. Okay. Now, this one. I have two congruent sides. I have another side that's shared, that's congruent to itself by the reflexive property. So for this one, I have side, angle, side. And then for this guy, I also have side, angle, side. So these are congruent by side, angle, side. Let me get rid of this extra stuff. Okay, last one. I already have two pairs of congruent sides marked. These triangles share their third side. So I mark that side congruent to itself, and I can say that these are congruent by side, side, side. Side, side, side. Okay, if you get it, you're done. If you want to see the last proof with me, come back with me to example 6. Okay, here we go. So I know from my given information that segment QR is congruent to segment QS. Those are sides of my triangles. So QR is congruent to QS. That was given. Okay, I also know that these two triangles share side QP. And the order of QP is the same in both of these, so I don't have to worry about flipping the letters around. And I really just did that. Here, go ahead and put the little bars on here. Here, add the bars everywhere if I didn't remember to add them for you. We got typos today. All right, so we know that segment QP is congruent to itself. QP, congruent to itself. QP. That is our reflexive property of congruence. Okay, next. I'm given some other juicy little tidbits. I know that ray QP bisects angle RQS. So whenever we have an angle bisector, we're going to get two congruent little baby angles. So this is my ray, okay, and it's bisecting this angle. So I can say, oh, that was given to us. Given. I can say that angle RQP, is congruent to angle SQP because of the definition of an angle bisector. Definition of angle bisector. Okay, now I have two sides congruent and I have my included angles congruent. I know that these triangles are congruent by side angle side. So that is triangle RQP congruent to triangle SQP. And we're done.